Don't I give you stuff for everything we do?
Let me guys practice test. Just making sure because.
What do you think? Chemical equilibrium. Did you know reactions are reversible? Have we ever used a double arrow right here? Kids? Zach, Brandon, this is primarily for you, okay? Shh. There's a forward reaction and a reverse reaction, okay? Shh. As I go over this, there will be things you will be able to do on the assignment sheet as a result, Dallas, of listening to this. Okay? All right. We have forward reactions and we have reverse reactions. All right? We have reactants that make products, and the products can turn around and make reactants. Okay? Now, does that happen in your candle burning situation? Does the carbon dioxide and water come back together to make candle wax? No. Why not, Zach? It's not reversible. All right? First of all, it can't be because what's happening to these gases when you're burning your candle? Where are the gases going? They're escaping into the atmosphere. They're not going to be in close enough contact where they're going to be forced to make more of the reactants all over again. Okay? All right. That can happen if you, now these are all gases too, but you can have this happen in a closed container. Okay? In a closed container, your gases can react as both reactants and products. Okay? All right. Now, there is something called Le Chatelier's principle that we're going to talk about. But before we do that, I want you to write this down. This is called the equilibrium constant expression. Eric, can you stand up and close the door, please? Ask those other boys to come back in, please. Shh. Ask the other boys to come back in. All right? All right. Now.
Okay, Lamar, be a little girl. Lamar said doesn't want to.
No,
stay up there.
Eric, quiet. Be quiet. All right. Now, this equilibrium constant expression, I'm writing it specifically for this equation. All right. Now, equilibrium expression has your products divided by your reactants. Do you know what those brackets mean? I don't think you do. The brackets indicate concentration in the units of molarity. April, remember molarity, right? All right. Now, where do you think these exponents come from? Where do you see that 2 in our chemical equation? Where do you see that 2? Put your pencils down and look up here and write. Stop writing and answer the question. What? Yeah, you see how this coefficient did what? It became an exponent, didn't it? Yeah. Okay. What happens to this coefficient of 1? What did it do? It came down here and became an exponent. What did this coefficient of 3? Came down here, became an exponent, right? All right. Products are always in the numerator. Reactants are always in the denominator. And the brackets tell us that we're looking at concentrations. So let me give you a question. All right. What is the concentration? Let's work this out. What's the equilibrium constant? Let's work this out, and then I'll give you a minute to copy this down.
Does that say KE12 or 2?
KEQ. This is an EQ for equilibrium.
so hungry.
Okay,
Catch for cover.
let's do this. Let's do this. Let's plug this in. What is my equilibrium constant? All right. Shh. Y'all see this? Ammonia. What is the, Austin Jones, what is the ammonia concentration according to my question? 2. All right. So I'm going to put 2 molarity. What do I do to that value, Austin Jones? Nope. Nope. What does this 2 exponent mean? Square it. Okay. Wait till I test you, see how it goes. Okay, now, nitrogen. Jones, what's the concentration of nitrogen? 2. What do I do to that concentration of nitrogen as far as my exponents are concerned? Yep. Just take it to the first power, which means we just leave it like it is. Corbin, what do I do to, what is hydrogen going to be? Hydrogen right here is 4 molarity. Now what do I do to this number? I can't just leave it here. What do I have to do to that? Yeah, hydrogen's exponent, because of that coefficient, is 3. So I'm just following this. All right. Now, the math should be relatively easy, but we also have to take into consideration our units. Zach, what is 2 squared? 4. Does everyone see that the units here are molarity squared in the numerator? All right. Now, Jasmine, what is 2 to the first, and what is 4? What is 2 to the first? 2, and then what is 4 to the third? What's 4 times 4? 16. What's 16 times 4?
18. Oh, 6 times 4 is definitely 24.
4 cubed is 64. What's 64 times 2? Lamar, is it 128? All right. What, Maggie, what are the units when I take molarity times molarity to the third? It becomes molarity to what power? 4th. All right. Y'all see what I'm doing? I'm having to deal with exponents, Dallas, on my numbers and on my units. Okay? Yep. Now, 4 divided by 128. Is that a small or a large number? David, 4 divided by 128. What kind of number is that? Is it going to be greater than or less than 1? It's going to be much less than 1. Now, what are the units of my final equilibrium constant? Zach, M. What is molarity squared? Divide by molarity to the 4th. What do I do with exponents? Treat it like a number.
So just try.
Yeah. What's 2 minus 4? Negative 2.
Yeah.
So there we go. Write that down. 0.031 molarity to the minus second. Tyler Carpenter. Do not use my book for that purpose.
Exactly